What is up, everybody? Today we are going to be looking at quadratic functions. So we're going to look at transformations specifically on quadratic functions. So let's jump right in. We want to look at how we can change up quadratic functions. So your basic quadratic function is just y equals x squared. So we can see we have our function here, x squared. And we want to look at different ways that we can move or transform this function. All right, so first of all, let's look at how we could move the function up and down. So that's the most simple. To move the quadratic function up and down, we just add or subtract onto the end of the function. So if we want to lift it up 3, we could just do plus 3. And notice that that function gets raised up. Similarly, if we want to lower it 3, we can just do minus 3. And there you go, your function drops down 3. Now what if we wanted to move it left and right? To do that, what we're going to do is we're actually going to add or subtract inside the x, or before we square it. So the way we could do that is over here, we're going to open up our x. So we're going to put some parentheses in here, and then right around the x, and then we're going to add or subtract right next to the x. So not onto the end, but right inside there. So if we did plus 3, notice that it moves it to the left. So this is a little bit backwards to what you would think, but if we add 3, that moves it left inside, and you have to be inside those parentheses. And you can probably guess what happens if we subtract 3. You're right, it moves to the right. All right, so if we add 3, it moves it to the left. If we subtract 3, it moves it to the right. But it has to be inside parentheses. It has to be inside the x. So if you want to move it up and down, it has to be out here on the end. All right, so that's 2 of our transformations. Let's look at how to do a reflection. So let's say we want to flip this thing upside down. So this would be a reflection across this x-axis. So if we want to flip this across the x-axis, we just put a minus sign out front. And you can see that that will flip the entire graph across that x-axis. But now what if we wanted to flip it across the y-axis? So what if we wanted to use this y-axis as our mirror, or reflect it across that axis? We can actually do that as well. That's called a reflection across the y-axis. And again, we'll put in our little parentheses and stick a minus sign right in front of the x. So not out front like we did a second ago, but just right in front of the x. And notice when we do that, nothing changes. Well, it actually did. It just didn't seem like it. This part right here got reflected across the y-axis over to this side. And this side over here got reflected over the y-axis over to that side. So it kind of got flipped right on top of itself, so it doesn't actually look like there was any reflection there. So that's what a minus sign inside the x does, is it will actually reflect it across that y-axis, and then a minus sign out front will just reflect it across the x-axis. So just know, minus sign out front, x-axis. If it's a minus sign inside the x, that's going to be across the y-axis. All right. Okay, let's look at our very last one, and that is stretches and shrinks. So if we multiply a number out front of the x, anything greater than 1 is going to stretch out our function kind of in the y direction. So it's going to stretch it out like taffy there in the y direction. And the bigger number we multiply by, the more it stretches it out. So, you know, if we did 6,000, you know, it's stretched out so thin you can't hardly see it. Now, what if we wanted to stretch it, or what if we wanted to like shrink it down in the y direction? So what if we wanted to compress it? So that's called a stretch when we multiply by a number bigger than 1. But if we want to shrink it, so if we want to compress it in the y direction or shrink it, then we're going to multiply by a number between 0 and 1. So like 1/5. So notice that that compresses it in the y direction. And the smaller the number, the closer we get to 0, the more it gets compressed. So if we did, 1/100th, and you can see that really gets flattened out. 1/1000th, even more so. So there you go, guys. Those are the different ways that we can transform a quadratic function. So we were able to shift it up and down. We were able to shift it left and right. We're able to reflect it in the x-axis and also in the y-axis. And then finally we were able to do stretches where we're stretching it this way, and then shrinks where we're kind of compressing it that way. But anyway, guys, that's all for me. I hope you enjoyed the video. If you did, leave a like, and I'll see you in the next one.